Measures of variability. That's what our focuses will be today. And we're going to talk about range and interquartile range. Range is something you've probably already talked about before. Interquartile range is a little bit different. It's going to be kind of fresh, so stick with me on that one especially. And let's hop into it. Now, measures of variability. Our whole goal of this lesson is to see how close our data set is, or how spread out our data set is. That's another way we could think about it. Now, range, this is how close or far apart the whole set of data is, and you're going to find this in two pretty easy steps. And interquartile range this is how far away the bottom half and the upper half is. Once again, not too terribly difficult. You're just splitting it into some different sections, kind of 4 pieces. So let's get started with the range. This is what it is and how you do it. The range is how spread out the data is. The first thing you do is I like to organize it from least to greatest. You don't have to, though. I'll show you that in an example. And then your second step, and the only other step you have, is subtract the largest data point from the smallest data point, and that will give you the actual range. So here's an example below. Here you have a list of numbers, 3, 7, 1, 12, 19, 11, and 26. What I like to do is I like to order it from least to greatest, but some people don't. They just take the biggest number, which is 26, and they subtract the smallest number, which is 1, and that is the range. Interquartile range, you're for sure going to have to order it from least to greatest, and it's just measures of variability where you're splitting up the data into some distinct sections. They're called quartiles, and you're seeing how far apart those quartiles are. Your goal is to have equal size quartiles also. So the steps will be listed as follow. The first thing you need to do is you need to organize this stuff from least to greatest. Got to do that first off. The second thing is you need to find the median of the whole set. And then, remember median's the middle number. Then you're going to find the median of the lower numbers before the median and the higher numbers after the median, also called quartiles, and you're going to subtract those to find the interquartile range. So here's an example. Here we have a list of numbers. It's going to be 19, 26, 42, 7, 11, 13, 27. We need to organize them from least to greatest. That's step 1. I like to always cross out the numbers as I'm going. That makes sure I don't miss anything or forget anything. 27 and 42. Then I'm going to find the median. The median middle number is 19 in this one. Now we're going to find the median of the lower set of numbers and then the higher set. The median of the lower set of numbers is 11. And the median of the higher set of numbers is 27. The way you do that is you just cross out from least to greatest. So we have these two. We have 27 and 11. And you're going to subtract the larger median from the smaller median. 27 minus 11 is 16. And this is the interquartile range. Basically, it's just seeing how far away the median of the little numbers and how far away the median of the bigger numbers are away from each other. This one's going to be the same thing applied, except you have decimals. Same thing. Once you have all the list of numbers, you need to first organize them from least to greatest. So we're going to order them, write down the number. I almost forgot the decimal there. Write down the number, cross it off as you go. 3.6, 4.0, 4.3, 5.8, 7.2, and 7.9. After that, you find the middle number. 4.0 is the median. Now, unfortunately for this one, if you try to find the median of the lower quartiles, you have 2 numbers. So you have to find the average of those. So you add them both together and divide by 2. And that means the median or the middle of those is 3. Then you find the median of these 2. You have to add these 2 together because they both fall in the middle. 13. And you have to divide those by 2. So the upper quartile median is 6.5. And then I subtract 6.5 from 3. And I end up getting 3.5.